Hello friends, welcome to Unreal Blueprints video tutorials series. From the past few video tutorials, we are trying to understand cos and sine function in Unreal Blueprint. I told you that cos and sine function accept angle as an input and return value between -1 and 1. Because cos and sine function work on unit circle. Unit circle is a circle whose radius is 1, guys. I also told you that if you know angle of an object, you can get or set its xy position using cos and sine function. If you know angle of an object, you can get or set its xy position using cos and sine function. For example, here I have x-axis and y-axis. If object is in this place, okay, it is a unit circle, guys. If object is in this place, okay, we know its angle is 0 degree. Cos of 0 degree gives you x position 1. You see, we have here x position 1. Sine of 0 degree gives you y position, which is 0. You see, here we have 0. If object is in this place, okay, if object is in this place, we know its angle is 90 degree. Cos of 90 degree gives us x position, that is 0. Here you see, we have 0. Sine of 90 degree gives us y position 1. You see, here y position is 1. If object is in this place, we know its angle is 180 degree. Cos of 180 degree gives us x position -1. You see, we have -1. Sine of 180 degree gives us y position 0. You see, here y position is 0. So, if you know angle of an object, you can get or set the x and y position of the object using cos and sine function, guys. Simple formula: x equal to cos of angle, y equal to sine of angle. In the previous video, we understood how to give circular motion or parabolic motion to an actor using cos and sine function. We understood how to rotate an actor in the level on xy plane with cos and sine function. We got the reference to the sphere from the level in the level blueprint and we implemented this graph. In this video, what we are going to understand is we are going to understand how to rotate a component of a blueprint class. How to rotate a component of a blueprint class on xy plane relative to its parent with the cos and sine function. Why? Because if you create a blueprint class, you can create n number of instances of it, right? That is the advantage of blueprint class. Once we create a blueprint class, we can create n number of instances of it. So let's understand how do we rotate a component on xy plane relative to its parent with cos and sine function. We create a blueprint class called bp_sphere. I go here, I right click and say new folder. I call this blueprints. Right click, create a class, blueprint class, parent class actor. I name it bp_sphere. You can see I created a bp_sphere. I add a component sphere. Sphere is added and its parent is default scene root. You can see that, right? Now I want to rotate this sphere on the xy plane. On the xy plane using cos and sine function. So I go to event graph, I get the reference to the sphere, drag a wire from it and I use relative location. Set relative location. What is the use of this node? Set the location of the component relative to its parent. Okay, let's put it over here and connect the execution pins. I put the sphere over here. Okay. Next, I right click on new location and say split struct pin. Okay, we got x, y, z separate. X equal to, what is the formula? The formula is x equal to cos of angle. X equal to cos of angle. So x equal to cos in degrees. I will select and I create a variable called as angle of type float. Compile. Angle initially will be 0 degrees. You see. And this angle I give it to cos. What is the next formula we have? Y equal to sine of angle. So y equal to sine of angle. So sine degrees I have selected here. I take the angle and give it to sine. And remember, cos and sine work on a unit circle. They return value between -1 and 1, guys. They return value between -1 and 1. Now what I do, I change the angle. Okay, initially it is 0, right? So I change the angle every frame by 1 degree. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like as I change the angle, the component, the sphere starts rotating on a unit circle, guys. Okay, what I do, I get this angle, I say add 1 degree and I say set angle here. So on every frame the angle changes 1 degree. So as we change the angle, our sphere starts rotating on that unit circle, guys. XY value change. If I say compile, save, come to level 1, I can create an instance over here. Okay, if I click on the play button, actually the sphere is rotating. I'll prove that. Here we have BP sphere, and in the BP sphere we have the sphere component, and you can see its X and Y value are changing. The sphere is actually rotating on a unit circle. Unit circle is a circle whose radius is 1 centimeter in our case. It is difficult to observe it is rotating. Let me change the radius of the circle itself. So how do we change the radius? We can increase or decrease the radius by multiplying the radius to the result of cos of angle and sine of angle, guys. So what I do, I go here, create a variable called radius in x-axis. I create one more variable called radius, radius in y-axis. We have two variables, you see that. I compile, I change the radius x to 100, radius y to 100, and then we multiply here. Let's select these two and move down, right click, and I use a multiply node, cos d and radius x. We multiply, result we set to new location x. Now instead of returning the value between -1 and 1, it starts returning value between -100 and +100, right? So -1 multiplied by 100 is -100, 1 multiplied by 100 is 100, right? Now I right click here and say multiply, connect here, radius y, connect here, result we connect to new location y. So now what happens? Our sphere rotates on a circle whose radius is 100, guys. If I say compile, save, come to level 1 and play, you can see that our sphere is rotating on a circle whose radius is 100. So if I want, I can increase the radius. Simply I go to radius x here, say 200, radius y, I say 200, compile, save, come to level 1 and play. You see, it is rotating at a bigger radius, right? At present it is rotating slowly. We can increase or decrease the speed of rotation also with the help of speed variable, which we multiply with the angle. Okay, so what I do, I come back to BP underscore sphere. Here I am going to create the variable called speed in x-axis. I create one more variable called speed in y-axis. Compile, speed in x-axis, let's say I'll give 5. Speed in y-axis, I'll give 5. Okay, which we multiply with the angle, right? At present angle is changing per frame 1 degree. So we can multiply this speed x and speed y. Right click and say here multiply, connect the angle, connect speed x, connect the output. Right click and say multiply, connect the angle, connect the speed y, connect the output. Now you can see our sphere is going to rotate more faster. Compile, save, come to level 1 and play. You see it is rotating more faster, right? So we can change this speed x, speed y value at any time. If I say here 10, speed y 10, compile and save, come to level 1 and play, you see it's rotating still more faster, right? So you can control the speed. If you want, as I told, the advantage of creating blueprint classes, we can have n number of instances, right? I create one more instance over here. Okay, I can create n number of instances. I create one more instance over here, and if I click on the play button, they all rotate at the same speed, right? So if I go back, change the speed in x-axis to 2, speed in y-axis to 2, compile and save, come to level 1 and play, you see now all of them are rotating slowly. If we want, we can control the speed on individual instance. How do we do that? By converting these variables to instance editable. So if I say speed x instance editable, speed y instance editable, what happens when we change speed x and speed y instance editable? Compile, save, come to level 1. If I select this sphere 3, you will see speed x and speed y available here. So let's say I rotate this speed at a slow speed, let's do 2. Okay, let me select this one. I change its speed x to 5, speed y to 5, and I change this sphere speed x to 10, speed y to 10. Now if I play, so it is rotating slowly, it is rotating faster, it is rotating still more faster, right? So we have the control of speed on individual instances. So this is the advantage of creating the blueprint class, guys. We can create n number of instances. If we want, we can control the radius also on each instance. So we can say simply radius x instance editable, radius y instance editable. Compile, save, come to level 1. I select this one. See, we can control the radius here. Let's say I want to rotate it like this, okay, parabolic motion. So y-axis, I increase the value here from 200 to 400, speed to 2. I select this one. This one I want to rotate normal, okay, and this one, let me reduce the speed to 3, and here I'm going to change the value to 400. So if I play, one rotates in a perfect circle. This is taking a parabolic motion, and it is also making a parabolic motion, you see that. So like this, you take help of cos and sine function to give a circular motion or parabolic motion to actors or components. So very useful mathematical functions, guys. And if you like this video, hit the like button and share with your friends. I suggest you people to try it yourself. If you try, you get more clear idea, guys. In the upcoming video tutorials, we discuss more about Unreal blueprints. For more benefits and be up to date, do not forget to subscribe to our YouTube channel. Keep learning, keep designing, keep sharing. Thank you, guys. Thank you very much. See you in the next tutorial.